Hi, in this video, we are going to see a distance vector routing algorithm. It is one of the types of the routing algorithm. In the previous video, I have posted about link state routing algorithm. It can also be called as Dijkstra's. In today's video, I am going to explain you about distance vector, which can also be called as Bellman-Ford routing algorithm. So, as I said earlier, the routing algorithms helps us to find the cheapest and the shortest path among the all the possible paths that exist between the source and the destination. So we will get into the routing algorithm. Yes, this is that is distance vector algorithm. It can also be called as Bellman-Ford equation, and it is also called as dynamic. It follows dynamic programming actually. So see the equation here, dx of y. What does it mean? Distance from x to y is equal to cost of the least cost path from x to y. Okay. Next, then what is dxy? Dx of y is equal to is min of v. V is nothing but all the nodes in the network. So min v of c comma x comma v, c of x comma v plus dv of y. So from x to y, to reach from x to y, we can also reach through the intermediate nodes, that is from x to v and v to y. Okay, so we have to check any other alternative path that exists through some intermediate node which is lesser cost than the direct path to y. If it is found, then we have to take the path which is of minimum value. If there is no minimum value path, then we can go with the direct path that exists between the x and y. That is the meaning of this formula. So cost of x to that intermediate node plus intermediate distance of intermediate node to destination. So obviously from x to y, whatever is the cost, that should be minimum compared to the path whichever is having a direct path between x and y. If it is minimum, then we can update. If it is not minimum, then we can go with the direct path. So cost from neighbor v to the destination y, as I said, cost to neighbor v. Yes. Bellman-Ford example. This is the example of Bellman-Ford problem. So they have taken an example network. Yes, see here, dv of z is equal to 5 and dx of z is equal to 3. See here, so from v to z, what is the cost? Which is equal to 5, and from dx, from distance of x to z is equal to 3, from x to z, which is equal to 3. Next, and dw of z is equal to 3. So distance from w to z is equal to 3. Yes or no? Z to w is z to w is 3. See, if whatever distance given here is not the direct path that exists between w and z. The last case, that is distance from w to z, if you take the direct path that exists between w and z. But what is the cost? It is 5. But if I move from z to y and y to w, then the cost is only 3. So I will be updating. Okay, so the same thing is done here. Then they have given another example, that is distance of u to z. If you check u to z, min of cost of, there are multiple paths, so they have taken 3 paths. I have taken 3 paths, that is from u to v, then v to z. The next path is u to x and x to z, and the next path is u to w and w to z. So we have to check among these paths which is the minimum one. If we find any minimum one, we can consider that, otherwise no need to consider it. So so if I see that 2 plus 5 7, 3 plus 1 4, 5 plus 3 is 8. So which is minimum here? It is 4. That is which is the best path here? The minimum path, what is that? That is u to x and x to z. So 1 plus 3, that is 4. So this is how we are calculating. Yes, see here, distance from x to y is equal to estimate of the least cost from x to y. As we said, this is distance vector equation, and node x knows cost to each neighbor. First, the initial step is, first it has to check with the neighboring immediate neighbor whatever is the cost to reach the immediate neighbor from the source node x, and maintain its neighbor's distance vector. For each neighbor v, x maintains dv, that is distance of v is equal to dv of y. So whichever is minimum, that will be taken. So distance from v to y will be maintained. Yes. So from time to time, if x and y are direct neighbors, the cost will be there. And what happens, from time to time each node sends its own distance vector estimate to the neighbors. So if a node is connected to 3 neighbors, and all the 3 neighbors will be sending it to or exchanging their routing table to all its own neighbors. So what happens, they will be coming to know, every node will be coming to know the shortest path that exists between one node to the other node in the network. See, I have 3 friends. In our group we have 3 friends, okay, including me, 3 are there. So I know the shortest path to reach Electronic City. My friend called X knows the shortest path to reach Banshankari. My friend Y knows shortest path to reach Anekal. Okay, so what we will do, whatever knowledge I have, that I will share to my friend X and Y, and whatever they have knowledge about the route to the other places, they will be updating to me. What happens, whenever I want to go to Banshankari, I will take the information my friend X. If I want to go to Anikal, I will take the information from Y. So we'll be keep on updating the information to reach the destination, every destination. So whenever the node sends the packet, the router sends the packet, it will be selecting only the shortest path, since it comes from the only the shortest path suggestion comes from all the neighbors. So it gets the suggestions from the neighbors, and it decides it updates the routing table with the shortest path. If at all the routing information which it received from the neighboring node not minimum, then it will keep the same value. If I find that whatever my friend X says, the route to Banshankari is not minimum cost path, then what I will do, whatever I know, the same path I will follow. That's it. The same concept is used in the distance vector routing algorithm. Yes. See here, distance of x to y is equal to minimum distance from v, that is cost of x to v plus distance of v to y. What is v here? It is intermediate node. Clear? The source is x and the destination is y. So to reach from x to y, if at all anybody can find the intermediate node which can take the packets, or which can route from the source x to y with the minimum path, then that will be considered as the shortest path. So v is nothing but intermediate node. It can be any intermediate node. If it is found, the routing table, if the minimum cost path is found, the routing table will be updated. Otherwise it will not be updated. It will maintain the same value. Yes. It undergoes iterative process and it is asynchronous. Local link cost changes every time. If minimum value is found, the link cost will be changing. Distance vector updates message from the neighbor. When it will be updating, when it will update is if it gets message from the neighbor. and it is distributed. Yes, it is not distributed in the sense it will not come from only one node, which is called centralized node. All the nodes will be sending the routing table information to all other nodes, so it is distributed. Each node notifies neighbors only when its dv changes, that is distance vector changes. If at all any change is there in the routing table, then only the every node will be sending the information to the its own neighbors. Otherwise no notification or no information will be shared or exchanged. So each node wait for changes in the local link cost or message from the neighbor. So it is waiting, every node will be waiting for the information. If it gets, it recomputes and estimates. And if any changes are there, if minimum value or minimum cost path is found after getting the message, it will also notify to its own neighbor that there is a route from x to v which is minimum than we have. So if at all it is useful for my neighbor, he will use, otherwise he will not use that. This is what happens. Yes, see here, from this is the way to calculate the distance vector routing table, your routing table using distance vector routing algorithm. See the node here, see the network, that is let me take the pointer to explain you. Yes, this is the network. From x to z and x to y and y to z, there exists a direct path. Okay. Oh, see, initially I'll be taking node x. Node x maintains a routing table. So what is the routing table of x is, first, this is the initial process. Just now I have initiated my router, let us assume. Okay, so first I have to start my values in the routing table. How can I process the values is, I'll take how many nodes are connected with me. I will check. So 2 nodes are connected with the node x. So what I'm going to do is x, y, z, and here cost to from x, y, z, cost to x, y, z. So like this I'll make a tabular column. Then I will see my network from x to y. What is the first value? From x to x. X to x, it is obviously 0. Unequal to unequal, what is the cost? 0 only. So x to y, what is the cost? X to y, it is 2. So I am updating here as 2. And x to z. X to z, the cost is 7. So I am updating as 7. At the same time, node y also wants to initialize the values in the routing table. So it takes its own routing table and it goes with y to x. What is the cost? Y to x, it is 1. Sorry, y to x is 2. So it makes this 2. And y to y is obviously 0. And y to z is 1. So y to z is 1. It is entering those values. Then node z also wants to initialize its routing table. So it checks from z to z. It is 0 always, and from z to y it is 1, so 1 is, and z to x is 7. There exists direct path to all the neighbors, so they are initializing with the cost whichever that exists in the link. Okay, this is the first step. And this, in the next iteration, what happens? Node x will send this routing table, the entire routing table information to z and y. Why it is sending? Because y and z are its own neighbors, direct neighbors. So it sends the routing table to y and z. Okay. And similarly, y also will send its own routing table, whichever it has prepared now, to x and z. Similarly, z also will send it to y and x. Okay. Once x gets the information or routing table from y to z, what it will do is, it will update its own routing table, because see, only whichever is directly connected to it was updated in the routing table in the initial step. All others were made as infinity. So it gets from y and it enters the value of the second row. See, 201 instead of infinity. And it gets from the z, routing table information, node x gets from the z and it updates the third row. So Now the node x information is complete. But when it gets the information from node y, it finds that x to z. So x to is y to z, it is finding that the value is 1. Okay, so we have x to y, the cost is 2. So there is an alternate path to reach to z from x which is lesser than the existing value. Yes or no? See here, see cost of x comma y plus y to y. That's what we found, that is 2 plus 0. Then from d of that is cost of x to z plus z to z to y is 8. So 2 plus 0 is 2 and 7 plus 1 is 8. So which is the minimum value here? It is 2. So it is going to take the same value, that is x to y is 2. But if you take the z value, if you check, from here I can find that the cost of y to z is 1. So the cost of y to z is 1 plus to reach from x to z. To x to y is 2. X to z can be reached with the value 3. But initially what we have done? 7. So with the information which it got from the node y, it replaces the value, the node x replaces the value to reach z as 3. So what was the information given by node y? It says that you can reach through me to z with the minimum value. Why? Because y to z the cost is only 1. So how can I reach to y? That is also said already, that I can reach, x can reach to y with the cost of 2, and from y to z it is 1. So through y if you go, node y says through me if you go, then the cost will be 3 to z. But if you go directly to z, the cost is 7. Now the node x comes to know the cheapest path, that is through y. The cheapest path through y is 3. So it is going to update its routing table. This is how every node will be getting the information from the other nodes and it will update it information in the routing table. Yes. See, whatever I explained, it is here. 2 plus 1 is 3. That is minimum of cost of x comma y plus y to z. Then another path exists, that is cost of x to z. That's what this 7, the path 7. So whichever is minimum, 3 was minimum, that is this 3 was minimum. So we are going to take this. Next. Once all the iterations happens, all the nodes interchange their routing table and checks the value, then what happens? Finally we will be arriving with these 3 routing tables with all the minimum paths in every routing table in the every node. So this is how. See, initially in the initial iteration it was 710, but if you find in the second iteration the cost from z to x is 3. How it found? It finds that to reach from z to x, initially it was found as 7, but when it gets the information from the other routing table, it found some other path whose cost is only 3. So it has updated. And as we discussed earlier, here also we have changed this as 3. And see here it is 7. When it goes to the next iteration, again it finds that from z to x we have another path that exists, that is whose cost is 3. So x to z, see, x to z is 3. Whenever we replaced here, the same thing is replaced here also, and it is sent to the node x, and now it is replacing as 310. Okay, and here See here, x to z is 710 here. So after replacing with the value from either x or z, it will also change its routing table to 310. So finally, at the third iteration, or if we have three nodes, after the third iteration, we will be getting the cheapest path in all their routing table. So this is how the distance vector routing algorithm works. So how it works? It just gets the routing information from its own neighbors. If it finds any minimum cost path from the other routing table, it will update its own routing table. Otherwise, it is not going to update. If it is going to update, if it is updated any information in its routing table, the same will be again circulated to its own neighbors. If it's useful, they will. If it is useful, they will accept. Otherwise, they will reject the information. So this is how distance vector routing algorithm works. So node detects local link cost changes, updates routing information, recalculates the distance vector as I said. If distance vector changes, it just notifies the neighbors. That's it. Yes. So the problem here is so many iterations happens. That is the disadvantage. And sometimes what happens, the routing table poison also happens by so much the same information is updated continuously. Because of so many iterations, the value may also go wrong. So that is also possible. That is the disadvantage, and it can also be called as infinity problem. So with this, I'm ending this video. Thank you. Bye.